In this video, we're going to talk about alkanes and how really specifically to name an alkane. So alkanes are referred to as saturated hydrocarbons. What that means is that every carbon in the compound is single bonded to 4 other atoms, and usually those atoms are hydrogens. So that means that it's saturated. Alkane, this ANE, represents the single bonds. Alkanes are single bonds. The simplest hydrocarbon is methane, CH4. Then you have ethane, C2H6, and then propane. You have C3H8. This carbon chain, so when carbons are single bonded or really bonded in order, in a straight line, then it can really be as long as you want. That's a carbon chain. It can be as long as you want, and a different molecule can actually be created by adding or removing a carbon from the carbon chain. Now, alkanes are usually unreactive because it's only CC and CH bonds, but there are some that are reactive. Typically, the most common example of an alkane undergoing a reaction would be combustion, a hydrocarbon plus oxygen. So you can actually see the chart in your notes for the names of the first 10 alkanes. You need to know the first 10, so from methane all the way to decane. So with the names of alkanes, in your notes, you have the molecular formula, you have the condensed formula, and you have the name. You also have the number of possible isomers of that alkane. On this slide, I have the boiling point. Notice that methane has the lowest boiling point and decane has the highest. What accounts for boiling point? Intermolecular forces. Well, what's going to be the strongest intermolecular force in any of these hydrocarbons? Dispersion. So as you add more carbon and hydrogen atoms, you're adding more electrons, and as you add more electrons, the molecule becomes more polarizable, creating stronger dispersion forces, which is creating higher boiling points. Now, just some simple uses of these alkanes. CH4 is methane, that's natural gas. That's the gas that comes out of our jets. Propane, AC3H8, that's actually in bottled gases. So that's heating and cooking fuel. Butane, C4H10, those are in the disposable lighters or fuel for camping. And then alkanes that have 5 to 12 carbon atoms, those are actually used in gasoline. So the stronger the dispersion forces become, the more that you change states of matter. So methane is a gas, butane can actually be bottled as a liquid, and then when the pressure is released, it becomes a liquid. And then as you get down to more and more and more carbons, it actually could become a solid. So when it comes to formulas, you can have a straight chain, or you can have a chain with branches. Now I want you to count up the carbon and hydrogen atoms in each of these. Well, this is C4H10 and this is C4H10, but notice that they look different. Okay, and they have different names. They have different properties. That's because of the way that they're connected. These are called isomers. So isomers are different structures, but they have the same molecular formula. We're going to be focusing on structural isomers. You can have structural or constitutional isomers or stereoisomers. Stereoisomers are when they differ in three-dimensional orientation. We're not going to worry about stereoisomers. What we're going to focus on is the structural isomer. So as you actually increase the number of carbons, you actually increase the number of isomers. So pentane has 3, hexane has 5, but once you get to 30 carbons, there's actually over 4 billion possible isomers with the formula C30H42. Now, you don't need to memorize how many isomers there can be. It's just important that you know that isomers do exist. So when we look at alkanes, it's important that you can distinguish between the different types of formulas. So before we look at the types of formulas, the biggest thing is that the formula for alkanes is CnH2n+2. So what that means is if I say I want you to write the formula of a molecule with 10 carbons, well then N is equal to 10, so it'd be C10H22. So I could give you any number of carbons and you should be able to write the formula for me. So as we look at formulas, you know just the molecular, okay, that's just the atom, C4H10. Structural is your Lewis structure. That's the full Lewis structure. It shows every single bond in the atom. And then we have the condensed structural formula. So essentially what we do here is that we almost minimize all of the H's and we put CH groups together. So this is CH3, this is CH2, CH2, CH3. Remember that every carbon atom wants 4 bonds. 1, 2, 3, 4. And then we have the line structure. And every one of these spots that I'm marking is a carbon. So this is the most simplest way to write a structure. So here's a C, here's a C, here's a C, and here's a C. The line structure, these lines that you see actually show the single bonds between the carbons. So we have a carbon here on the end, it's single bonded to one more carbon, which means this carbon still needs 3 more bonds off of it, which is why we get the CH3. So here's a sample problem. Okay, draw the structural formula, the condensed structural formula, and the line structural formula for heptane. So the first thing that you want to do is you want to look at the name, heptane. Okay, that's 7 carbons. So we have 7 carbon atoms. They're all single bonded together because of ANE. So we have the structural formula. You just line up 7 carbons, single bond them together, and then remember, carbon wants 4 bonds, so then you just fill it in with hydrogens. The condensed structural formula can be like this one on the top, where we just minimize all of these and create CH groups, or you can actually do what's on the bottom. And what we're doing is almost like combining like terms. You have 1, 2, 3, 4, 5 CH2 groups in the middle. So we have CH2 in parentheses with a 5. Now we can't combine these CH3 groups because you have to show this exactly how it's written. So you want to see exactly how this is written. So you have a CH3 group on one end and a CH3 group on the other. And then the line formula, again, every one of these represents a carbon. So 1, 2, 3, 4, 5, 6, 7. And it's all single bonds. So now we're going to get into the actual naming part. So IUPAC Nomenclature. IUPAC is the International Union of Pure and Applied Chemistry, and in 1892 they actually established a system for naming compounds. Now, some of them are still changing. Okay, some of the naming is still changing, but we're going to go with some of the older naming. So this is guidelines for naming alkanes. Alkanes hasn't changed. The chemical name has 3 parts. There's a prefix. So what are the substituents? A substituent is a group that's attached to the main chain of carbons. Then we have the parent name, so that's how many carbons. So is it 6, is it 7, is it 8? And then suffix is what family is it in. We're focusing on alkanes, so your suffix is going to be ANE. Okay? ANE tells you that it's an alkane, which means it has all single bonds. So when we look at the parent name, what we have to do is we have to find the longest continuous carbon chain. So what that means is you have to keep going in order. You can't turn around and go backwards. So if we look at this example down here, we could have 1, 2, 3 if we bend, because you can bend, but that's not our longest. We could have 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5. So either way, the longest chain is 5 carbons. So what that means is our parent would be pent. And with the suffix, it would be pentane. So then really all we have to focus on is what are the groups that are attached to the main parent chain. So those prefixes are used to indicate the group, like I said, attached to the parent chain. If the group contains only carbon and hydrogen atoms, that's called an alkyl group. Okay? Notice the ALK, that means it's similar to alkanes. But instead of adding the ANE, we dropped that and we had YL. That tells us that it's a group that's attached to a parent chain. And the specific name is actually derived from the alkane with the same number of carbons. So for example, one carbon group, right, one carbon, if this were the parent chain, it would be methane. But it's attached. This line with nothing off of it, that tells us that it's just attached to the parent chain. So this is a methyl group. If we have 2 carbons, that is an ethyl group, right? This is attached to the parent chain. And then 2 groups can actually be derived from propane. So if it's in a straight line, okay, if all of your carbons are in a straight line and your parent chain is right here, that's a propyl group. Okay, notice that it's attached to the end carbon of the 3 carbon chain. The other one is the isopropyl group. Okay, isopropyl, it's still 3 carbons. That's why it has the propyl. But the iso means it's attached to the center carbon. So the parent chain would be right down in here. And notice that it actually can be represented different ways. This is the full structure, but in each of these you're also given the condensed structure, because a lot of times you'll be given the condensed structure. So you can see your notes for other alkyl groups, but you need to memorize these. So you have methyl, ethyl, propyl, butyl, isopropyl, and tert-butyl. You also have fluoro, bromo, iodo, all of those in the little box in your notes. You need to memorize those. When we talk about alphabetizing, this isopropyl, this is all one word. Okay, so when we talk about alphabetizing, isopropyl is one word. This tert does not count when we alphabetize. Okay, this tert does not count when we alphabetize. So then, the location of the substituent groups, whether it's an alkyl group or whether it's another group like bromo, okay, they're designated by numbers. So here's the steps that we go through when we name an alkane. So the first thing you do is you name the longest chain. So find the longest continuous chain of carbons. That's going to be your parent name. Now, the longest chain may not always be obvious because sometimes it can bend. So for example, here, this is actually our parent chain, the one that's boxed, because notice if we start down here, 1, 2, 3, 4, 5. Our longest, if we go straight across, is 5. But if we go 1, 2, 3, 4, 5, 6, the longest is 6 chains. So our parent chain here is a hexane. Don't go backwards. Don't say 1, 2, 3, 4, 5, 6, 7. That doesn't work. You can only go forward. And then the second thing that you do is you number the carbon atoms in the main chain. Now when you number the carbon atoms, start numbering it closest to the first substituent. So closest to the first group that comes off. So notice that there's a right way to number and a wrong way, because if we go 1, 2, 3, 4, 5, 6, this branch, right, this group comes off of the third carbon. If we go the other way, it comes off of the fourth carbon. You always want your groups, so any group that comes off, any branch that comes off, you always want it to have the lowest number possible. So then you want to identify and number the branching substituent. So you actually assign a number to that carbon, because then that actually tells us, this is like an address, that tells us where it's located. So we already said this is a hexane. Now, if you look back, what's a CH3 group? It's a methyl group. So we have a methyl group coming off of the third carbon. If you have two substituents on the same carbon, you assign the same number to both. This is going to be a key part of this. You always need as many numbers in the name as there are substituents. Okay, so if you have, in this case, we have a group here, and we have a branching group here. So CH3 is methyl. Now, here we have 2 carbons in a row. That's ethyl. So we have a methyl group on the third carbon and an ethyl group on the third carbon. Then what we do is we write the name as a single word. Now, as you're writing the names as a single word, you use hyphens to separate prefixes. The only time you use commas is if you have numbers right next to each other. Like right next to each other, that's when you use commas. Otherwise, you use hyphens for everything. If you have 2 or more different substituent groups, so you have different groups attached, like in this second example, these are 2 different groups. You list them in alphabetical order, not numeric order. Always alphabetical. If 2 or more identical groups are present, okay, so in the case, let's say we had 2 methyl groups present, then you're going to use a prefix like di, tri, tetra, and so forth to tell us how many there are. And we'll look at some examples of that. But you don't use prefixes for alphabetizing. The only prefix you use when alphabetizing is iso. That's the only one you use. So here are some examples to see how they're written. So notice the parent chain is already numbered. You guys have already said this is a methyl group. So the way that we name it is 3-methyl hexane. Okay, the methyl group comes off the third carbon, so 3-methyl hexane. Whenever you have a group with the parent name, you always combine them if that's the last word. Then if we look at this one, here we have an ethyl group and a methyl group. They're off the same carbon, so this will be 3-ethyl and 3-methyl, but put it in alphabetical order. So 3-ethyl hyphen 3-methylhexane. Notice you're using essentially a hyphen for everything. Then this one down here, notice the parent chain is numbered again. It bends. So here we have a group coming off, and here we have a group coming off. Both of these are what branching groups? Methyls. So notice they both come off the 3rd carbon. You need as many numbers as branching groups. So this is a methyl, this is a methyl. So we have 2 methyl groups. That will be dimethyl. But we have to put numbers out front. So we do 3, 3. You have to put the same number twice. Even if it's the same number, you have to put it. 3, 3 hyphen dimethylhexane. Because this tells us we have 2 methyl groups, both at the 3rd carbon, with a hexane parent chain. So we're just going to do one sample problem to end this video. So give the IUPAC name for the compound represented by this formula. So the first thing that you always want to do is number your longest chain. So I have 1, 2, 3, 4, 5. So I have 1, 2, 3, 4, 5. I also could go 1, 2, 3, 4, 5. I could go, that's it, right? 5 is the longest. So what is going to be our parent name if we have 5 carbons? Okay, it's going to be pentane. So we know the longest chain is 5 carbons. That is pentane. Now, what we need to do is we need to make sure that we number correctly. Right now we have groups off of the 3rd and the 4th carbon. Now, is there another way that we could potentially number this? Well, we could go 1, 2, 3, 4, 5. Because now, if you look at the blue numbers, the branching is off of the 2nd and the 3rd carbon. You want the lowest numbers possible. Now, what are these CH3 groups? They're methyl. So we have 2 methyl groups attached to the 2nd and 3rd carbon. Okay, not the 3rd and the 4th. You want the lowest number possible. So we want to make sure we give the methyl groups the lowest numbers possible. So we have 2 methyl groups, which means we're going to have dimethyl. Okay, but what number should we put out front? We're going to do a 2, 3 hyphen dimethyl pentane. So the correct name for this is 2,3-dimethylpentane. And you have other sample problems, so try those sample problems in your notes. See if you can get some of those. And not only are you going to be going from the formula to the name, but they're also going to have you go from the name to the formula.